In this chapter, we're going to define some numbers that represent a data set. We're going to begin with the definition of mean and median. Mean and median represent the center of the data set. So if we have numbers x1, x2, x3, so on up to xn, the sample size is n, so that is the size of the sample. The mean of this data set is the same as the average of all these numbers. So how do we find the average? We just add all the numbers and divide by the total number of numbers. Another way of writing it is, as you see here, the symbol sigma just means summation. So you sum all the numbers xi. I ranges from 1 through n, but then you have to divide by n. So this is just another way of defining the mean, which is denoted by x bar. Now the next question is, does mean or the average have any units? So let's think about this. If I have two numbers, 3 centimeters plus 5 centimeters, and I add the two numbers, both the measurements are in centimeters. My total is 8 centimeters. Now if I want to find the average measurement, I just divide the 8 centimeters by 2. The 2 cancels with the 8 and our answer is 4, but the centimeters remain, so it is 4 centimeters. So yes, the mean does have units because we are just adding numbers with the exact same unit and then dividing by a number n. So that's the reason why the mean has units. In the first problem, we have a set of numbers. These numbers represent the incubation period of a certain illness, and this comes from 18 people. So the sample size is 18. Each number represents the time in hours between eating the infected food and the first signs of illness, and the illness is food poisoning. Now the first thing we do is make a stem plot. So if you recall from the previous section, this is the key to the stem plot. So 1 and 2 together make 12. So these are all the numbers in the form of a stem plot. So what is the shape of the distribution? Notice that there is a skew to the right. There are larger numbers which are far removed from the rest of the data set, which is all here. So these numbers are high outliers. So this creates a skew to the right. The spread, one way of describing the spread is by subtracting the minimum value from the maximum value. So 86 hours is the maximum incubation period and 13 hours is the minimum incubation period. So the difference is 73. So the range is 73 hours. Let's not forget the units. Now we need to find the mean incubation period. These are instructions to finding the mean of the given set of numbers using Crunchit, and these are the set of instructions to find the mean using your TI-83 or above calculator. So either using Crunchit or the calculator, and you would have to know how to use both, the mean denoted by X bar is 35.78 hours. We've just defined a number that represents the center, and that is the mean. Mean is the average. We add all the numbers and divide by the total number of numbers. The next number we're going to define is the median. Roughly speaking, the median is the middle number in the data set when the numbers are arranged in some sort of order, that is, either ascending order or descending order. The next question is, does the median have units? So if the median is just the middle number and the middle number has units, obviously the median also has units. So the answer is yes, it does have units because it's just one of the numbers in the data set. In the second problem, we're given a set of numbers and we need to find the median or the middle number of these numbers that are given to us. So let's just think about this first. What if we had three numbers, 4, 7, and 9? The sample size n equals 3. Just note that this is an odd number. Now it's easy to identify the middle number when we have only three numbers. We have 7 in the middle and one number on either side of 7. And before we determine the median, just remember to put it either in the increasing or the decreasing order. Now let's think about it another way. We have three numbers in the list. So we have 4, 7, and 9. So n is equal to 3. If we add 1 and divide by 2, we have 4 divided by 2, which is 2. This is another way of identifying the position of the median. This 2 tells us that the second number is the median. So when the numbers are arranged in order, the second number is the median. So what we just did was used the formula number of numbers, which is n, the sample size, plus 1, and the whole thing is divided by 2. This is a way of identifying the position of the median. The second number is the median, and the second number in this data set is 7. So that tells us that the median of this data set is 7. Now let's see if the same logic works for the next example. Here we have an example of a data set with 5 numbers. 5 is again an odd number. So when there are just 5 numbers, it is easy to identify the middle number, and clearly the middle number is 9. Now let's see if the same formula we used here will work for us. So we have 5 numbers in the list. So n equals 5. 5 plus 1 divided by 2, so we are using the exact same formula, is equal to 6 divided by 2, which is 3. Using this number 3, can we confirm that the third number is the median? And clearly that is the case. The 9, which we identified as the middle number, is really the third number. So by the same logic, we can determine the position of the median quickly by using this formula. This would work as long as n is an odd number. Now let's think about the problem that was given to us. We had a set of numbers, all in centimeters. What we first do is arrange them in either ascending or descending order. Identify the sample size. The sample size is 11. Again, 11 is an odd number. So let's see if the formula works for us. So we take n, which is the sample size, add 1 and divide by 2. So 11 plus 1 divided by 2 is 12 divided by 2, which is 6. This 6 is not the median. This 6 gives us the position of the median. So it's the 6th number that we should be looking for. And let's look at the 6th number. So that's 1, 2, 3, 4, 5, 6. So the sixth number, which is 3, is the median of the given set. And remember that the median has units, so we say 3 centimeters is the median or the middle number of this data set. Let's look at the next example. So we have a given set of numbers. Let's again assume that the numbers are all are measurements in centimeters. So the first thing we do is arrange the numbers in either increasing or decreasing order. So here we've arranged it in increasing order. Now notice that the sample size or the number of numbers we have here is 10. 10 is an even number. If it's an even number, we cannot find one middle number. The set with an even number of numbers would have to have 2 middle numbers. So these two clearly are the 2 middle numbers. So how do we figure out the median of this data set? We take the average of the 2 middle numbers. So 3 and 4 are the middle numbers. We add the 2 and divide by 2 to find the average to get 3.5, and remember to attach the units. So the median of this data set is 3.5 centimeters. Now let's look at it another way. Can we locate the position of the median without actually looking at all these numbers? We start off with the sample size n, which is equal to 10. So 10 is an even number. If we divide 10 by 2, what we get is 5. This 5 does not give us the median or any number in the data set. It just gives us the position of the first middle number. So the fifth number is our first middle number. If we add 1 to the fifth number, so 5 plus 1, that is equal to 6. And the sixth number, which is the next number, would be the second middle number. So this is another way of identifying the 2 middle numbers. Now once we know what the 2 middle numbers are, all we have to do is take the average of the 2 middle numbers, and that would give us the median. So this is the fifth number, and this is the sixth number. So that's just another way of locating the two numbers, middle numbers, so we can find the median by taking the average of the 2 middle numbers. What you see here is a set of instructions to find the median using Crunch It, and also finding the median using the TI-83 or above calculator. Now, if you follow the instructions for the TI-83 calculator or even the Crunch It instructions, you're not only going to find the median, but lots of other information like the mean, the lower quartile, the upper quartile, Q1 and Q3, which we're going to discuss in the next part. You're also going to see the minimum and the maximum. You're going to see the sample size. You're also going to see what's called the standard deviation, which we'll discuss at the end of this chapter. So if you follow the instructions, one of the numbers will be the median. In problem 3, notice that you're given two sets. One is sample 1 and the other is sample 2. Another thing I want you to notice is that the two samples are almost identical except for the last number. The last number in the first set, compare it to the last number in the second set. One is 7, the other is 70. The second set has a high outlier. Other than that, both the samples are pretty much the same. We find the mean of the first set, and that is 3.62 years, and the median is 3 years. We again find the mean and the median for the second set of numbers. Notice how the mean changes it's about 8.42 years, whereas the median remains the same, which is 3 years. So the high outlier changed the mean because the mean adds all the numbers and then is divided by the total number of numbers. But the median remains the same, which is 3 years. So the high outlier didn't change the median. I've specifically picked this example to show you that the mean is not resistant to the outlier. It changes, it goes in the direction of the outlier. If the outlier is high, the mean gets pulled in the direction of the outlier. Notice that it's become 8.42 because the number has changed from 7 to 70. So the mean gets pulled in the direction of the outlier, in the direction of the skew, because this second set has a right skew, whereas the first set is roughly symmetrical. So the first symmetrical distribution, and compare it with the second one with the right skew, the median remains the same. Both medians are equal to 3. So the median is called a resistant measure. The outlier does not affect the median in this case. Now we've talked about how the mean and the median are both measures of the center. If a distribution is roughly symmetrical, then both the numbers, the mean and the median, represent the center pretty well. But if there is a skew, as in the case of sample 2, so we're looking at this sample, if it has a skew, then if you look at the two numbers, the mean and the median, it is pretty clear that the median is the better representative of the center of this distribution. Now in the fourth problem, notice that we are given the sample size. It's 1234 numbers, and the important thing is that they're all arranged in order. Now, can we locate the median without actually knowing what the numbers are? At least can we find the position of the median? Now, we reviewed this in the first slide. The sample size n is 1234. It's an even number. Remember that if it's an even number, there are two middle numbers in the data set. If we can locate one, then the next number we get by just adding 1 to that position would be the second middle number. And once we locate the two middle numbers, all we have to do is take the average of these two numbers. So we don't know what the numbers are, but at least we can find the position or the rank of these numbers. Since it's an even number of numbers, all we have to do is take the sample size and divide it by 2 to get 617. So the first middle number in this data set that contains 1234 numbers is the 617th number. We add 1 to it, and that is the 618th number. So the 617th and the 618th numbers are the two middle numbers in this data set. If we know what these two numbers are, then all we have to do is take the average of the two numbers, and that would be the median of that particular data set. Now what if we had 1235 numbers in the data set, and they're all arranged in order, either increasing or decreasing? Now notice that 1235 is an odd number. So there is one middle number. There is just one middle number, and we can locate it using the formula n plus 1 divided by 2. N is the sample size, so we add 1 to the sample size, divide by 2, and we get 618. Now 618 is not the median. However, the 618th number is the median or the middle number. Let's quickly review what we did in this video. The mean and the median are measures of the center of the distribution. Do the mean and median have units? The answer is yes. We discussed this. Both have units. Do you know how to use your calculator to find the mean and the median? It's important for you to know how to use your calculator. Make sure you're using it in all the calculations because when you are taking a test, you're allowed to use your calculator. You will not have access to your computer to use Crunch It. Given the sample size, and this is important, can you find the rank of the median? So we've looked at two cases. One is when n is an odd number. N is the sample size. If you have an odd number of numbers in your data set, there is one middle number, and that would be the median. Can we locate the one middle number? We can use the formula n plus 1 divided by 2, which means add 1 to your sample size, divide by 2, and that gives you the position or rank of the middle number, the one middle number. It doesn't give you the median, but it gives you the position. If you can find that middle number using the position that we calculated, then you know what the median is. If n is even, then remember that there are two middle numbers in the data set. So what we need to do is locate the two middle numbers and then take the average of it, and that would be the median. So take the sample size divided by 2, and that gives us the first middle number. And take the sample size, divide by 2, and add 1 to it, and that gives you the location of the second middle number. So once we have the two middle numbers, all you have to do is take the average of those two numbers, and that would be the median. So notice here that what we can do is calculate the position, not the numbers. We need to see the data in order to figure out what the number is. Which measure of center gets influenced by the outlier? Clearly, the mean gets pulled in the direction of the skew. If it's right skewed, the mean gets larger. If it's left skewed, the mean gets smaller than the median, but the median remains in the center. So what gets influenced by the outlier is the mean. Which measure better represents the center of a skewed distribution? The mean gets pulled in the direction of the skew, so it doesn't remain in the center anymore. So the median is always a better representative of the center in the case of a skewed distribution.